Hello everybody, this is Rudra Pradhan here. Welcome to BMD lecture series, and today we will continue with prescriptive analytics, that too coverage on linear programming problem. In the last couple of lectures we have already discussed this prescriptive analytics, and that too we have highlighted couple of issues like optimum solution and how to achieve optimum solutions in a kind of maximization problem and minimization problems, and the idea behind this particular structure is to get the values of the decision variables corresponding to a particular business problem and the kind of management requirement. So, technically we have solved some of the problems, that is type of maximization case and the minimization case, that is with respect to objective functions and the constraints, and the problems which you have solved for the management requirement or the business requirement, where we have a normal case, that too with respect to objective function maximization type. The normal situations are the constraints must be in the less than type, and in the case of minimization problem, and that too minimizing the objective function, and as usual the constraints will be greater than types. So, accordingly we have solved cases for maximization problem where the constraints are less than type, and solve some of the problems less than type where the constraints are greater than types. So, usually in the normal linear programming problem corresponding to maximization problem, constraints should be less than type, and corresponding to minimization problem, constraints should be less than type. So, now if the situations are other way around, for instance having objective function maximization type, the constraints are greater than type, and with respect to minimization of objective function the constraints are less than type, or in the third group with respect to maximizing objective function or minimizing objective function where the constraints are not in a kind of consistent structures like typically less than type or greater than type. So, that means technically irrespective of objective function maximization and minimizations, and the constraints are kind of mixture kind of situations where we may have less than type, we may have greater than type, and we may have equality type. So, that means it actually depends upon a particular business problem, and corresponding to business problems the idea is to formulate the LP subject to the objective functions may be maximization type and minimization type, and then the constraints will be follow up as per the kind of business problem or the kind of management kind of requirement. And so, once we design the models, then we will look for the kind of solutions. So, we have no issue to solve the problems irrespective of maximization of objective functions, minimization of objective functions subject to constraints which are not in a kind of typical format, the less than type or greater than type, where we may have actually mixture type. So, the idea is that we may not have any problem. So, the first step of the particular process is we like to streamline the process depending upon the particular objective, maybe maximization type or minimization type. So, in totals we have solved problems and looking for optimum solutions in the case of maximization and in the kind of minimizations, where the problems are more or less consistent without any obstacles or without any kind of issues or some kind of complexity. But in reality irrespective of objective functions maximization and minimizations, then the mixture kind of constraints we may find some kind of abnormal cases, and and the kind of special cases where the objective function and constraints may not give you some kind of unique optimum solution. So, now we like to address these issues in this particular lecture. In reality there are certain business problems which may have such kind of indications, then we should know how to solve these problems and look for the kind of solution, or giving the kind of indication, so that management decision can be taken into considerations. So, now to highlight all these things, some of the special cases or issues, like sometimes we may not have no feasible solution. So, the kind of structure is like this. Sometimes we may have objective functions, maximization or minimization, and the constraints may be consistent, may be some kind of mixture. Still we may not every time get the feasible solution. So, that means technically we like to know what are these specific cases where you may not have no feasible solution, irrespective of objective function and the kind of constraints. And the second special issue is sometimes the problems is unbounded type. That means this may be the case where objective function and constraints may not be consistent as per the particular business requirement or the kind of management requirement. In that case, we may not be in a strong position to come with a kind of management decision for a specific problem. And the third special case is the redundant constraints. That means technically the usual structure of LPEG, we must have objective function and then subject to certain constraints, maybe typically less than types or typically greater than types or typically the mixture of both less than type or greater than and greater than type, and sometimes maybe equality type. But while doing the kind of solutions where the optimum solution is with respect to objective function, the constants must be consistent, then in the process of optimality, some constants may not be actually effective, and as a result it can be called as redundant. So, that means in the final optimum solution this may not be the kind of linkage towards the optimum solutions. So, it may be the case of the dominance of other constraints to the objective function. And the fourth special issue is the multiple solutions. That means technically the usual structure of optimization or prescriptive analytics is that we like to find out the corner points. That means every corner point may be in a position to give optimum solutions. So, now after knowing the corner points, so we like to put all these corner points to the objective function and try to fix the particular point for optimality, where the value of a objective function will be maximum for a maximization problem and extremely minimum for a minimization problem. But we may find some special case where the values of the objective function are equal at two different corner points or three different corner points. So, in typical situations our structure is called as a problem having multiple optimum solutions. So, these are all called as special cases, and we like to see what are these special cases and how is this particular structure graphically, and then we like to connect the LP structure with different application, that too in the kind of management domain. So, that means typically we like to know how prescriptive structure is all about, and in a kind of problem like marketing, finance, operation research, the kind of HR. So, that means typically in a kind of business environment, prescriptive analytics is a kind of typical technique where all kinds of problems can be connected, if provided it must be fitted with the linear programming format, and then looking for the kind of solution and the kind of management decision. And by the way, so we will see first in the case of maximization, right. This is a strongly normal case for maximization problem, where the objective function is typically the kind of maximization type, and then the constants are typically less than type. So, this is the normal case of the kind of LP problem, and that too the that to the case of maximizing the objective functions, and this problem we have already discussed. And in the counterpart, the kind of solution will be like this, and we like to plot the constants as per the particular structure, and finally we look for the corner point, and then think about the value of the objective function corresponding to these corner points, and where the value is the highest, that will be the final optimum solutions in response to maximizing the objective functions. And contrary to the maximization type, the minimization problem structure will be like this. The objective function as usual minimizing z subject to constants, and that too. So, this is the minimization kind of structure where so the z is the minimization type, and the kind of constant is typically greater than type. So, that means technically this is the normal case of minimizations corresponding to objective function, the constant should be greater than type, and as usual there will be restriction for decision variable that should be positive in nature. So, this is a as usual structure of LP problem, and corresponding to the maximization problem. So, this is how the structure about the minimization problem, and accordingly we are looking for the solutions, and the solution will be also we try to find out the feasible zone, and then looking for the corner points, and then looking for the kind of optimality by putting all these corner points value to the objective function and fixing the optimality. So, this is the typical case of minimization problem. So, that means technically, so this is how the structure about the maximization type, and this is how the structure of the minimization type. That means the feasible zone will be in the upper side, and we are looking for the bottom of the sides, and in the case of maximization type, we like to fix the boundary, and then the solution will be within the particular boundary. So, that is the typical difference between the maximization structure and minimization structure, and in the case of prescriptive analytics, and that too in a kind of linear programming situations, or the kind of management problem. And corresponding to the kind of maximization case and minimization case, that too in the normal situation. So, we have already cited two different examples, and now we come to the kind of special case. So, the first special case is the infeasible solution, and typically the objective function may not give you the kind of optimum solution as per the particular business requirement or the kind of management requirement, and it may be the situation where corresponding to a particular objective functions, may be maximization type, may be minimization type, but the constants are not consistent. For instance, if there are two variables, say x 1 and x 2, means since we are doing the graphical kind of indication to know the normal case and the kind of special case. So, the objective functions may not reach the optimality if the constants are not consistent. For instance, if there are two constants, one will be greater than type and another one will be less than type, and that is the typical kind of situation where you may not get the kind of optimum solution. The reason is that we may not in a position to find out the feasible regions through which we look for the corner points and look for the kind of optimum solution depending upon the kind of objective functions. So, that means this is a typical case here, and here so the typical arrow indication represents that it is the greater than type of constants, and this arrow indicates that it is the less than type of constant. That means we have constant A and constant B. Constant A is the kind of less than type of constant, and constant A is the greater than type of constants. As a result, so to have a different kind of structure altogether. As a result, optimality may not possible, and as a result we may not in a position to solve the business problem, and may not get a kind of solutions. So, this is a kind of inconsistent problem through which actually we may face in the case of management problems, and as a result we may not get a optimum solution. And this is a typical case of another typical case, that is the special case that is called as unbounded case. And this is a kind of situation where your objective function is the maximization type and the constants are typically greater than type. So, that means technically, so looking here the indication of arrow. So, it gives the indication that it is the kind of greater than type of constant, and this is also greater than type of constant, and this is also greater than type of constant. So, that means technically the zone will be in the right side, and we are looking for maximization of z value. So, in this case in this case your boundary is not actually finite. So, it is actually unbounded. Typically, so the feasible zone has no boundary. So, as a result, so you may not in a position to find out the all possible corner points, and as a result you may not get the optimum solution. So, this is the second special case you may face in the case of optimality or in the kind of prescriptive analytic structure. And the third special case is the redundant constraints. So, that means what I have mentioned already. So, having a kind of problems, maximization problem or minimization problem. So, sometimes few constants may dominate the kind of structure in such a way that you may get the objective values of the objective function, and you may get the optimum solution, but all the constants may not finally in a kind of operative. It may happen sometimes, because as per the particular requirement. So, the out of 3 constants, 2 constants are satisfying the case, and as a result you may be in a position to get the optimum solution. For instance, so this is a kind of if you look the arrow, so it is the less than type, and then the feasible zone will be accordingly this much, and then this is also the case of second constant, the indication is also less than type. So, as a result, so your feasible zone will be also in the less than type. Now, if you connect the first constant and second constant, then technically the feasible zone will be only here. So, this will not be actually counted. So, that means, so the first constants will dominate heavily, and again, so coming to this particular constant, third constant, which is also less than type, but it is too much above. So, that means this particular constants by default give you the kind of structure that optimum solution by default will be lying in these 3 corner points. So, as a result this is not so effective and this is not so effective. So, but we are getting the optimum solution corresponding to the objective function, but these constants are not so effective in the kind of optimum solution. Sometimes it may happens depending upon the kind of business problem and the kind of management problem. So, this is the third case, a special case about the kind of prescriptive analytics, and then the fourth case is the multiple optimal solutions, and here. So, the constants are consistent corresponding to the objective function, but this is the case where at least 2 different corner point, the value of the objective function is more or less similar. So, if that is the case, then this will indicate that multiple optimum solutions, or sometimes alternatives. This is what I called as alternative solution, that means corresponding to a particular objective function. So, there is another point where the objective values of the objective function is more or less same. So, this is the case where we can call a situation that the problem having multiple solutions. So, that means it is flexible, often flexible, because when we are looking for the optimum solutions, we must have a flexible points. Then we are checking and then declaring that this is the kind of optimality. Now, within the flexibility, 2 different situations where the values of objective function will coincide, and at least 2 different situation, then as a result. So, this is the declaration about the multiple optimum solution. So, now if a particular problem is having indication about the multiple optimal solution, that means it is good for the kind of business problem or the kind of management problem. That means management decision will be more effective and efficient, because we have the kind of alternative, and that too it is called as a situation called as opportunity kind of best kind of situations, where you can choose any of the two and as per the particular requirement. Of course, the combination of the values of the decision variable will be different, but the objective function value will be remain same. Sometimes depending upon the particular requirement. For instance, we have already discussed the case that economic feasibility and social feasibility. So, now if you have a such kind of situation where the solution is multiple types, then you can choose a particular option which may not affect the objective function, and then it may reach the social objective rather than economic objective. That means, technically in this kind of situations we have this concept called as sustainability kind of situation, where we can take care both economic objective and social objective. And sometimes it is a very rare, but of course, if you have the kind of situation, this is good or plus point for the kind of management, so that they can come with effective management decision. And some of the other issues are there in the linear programming, like issues in formulating problems. So, first thing is the degree of simplification of the real world problem, and violation of the some of the LP assumptions, like additivity, certainty, proportionality, divisibility. And the linear programming problems may include different type of decision variable definition, and different types of constraints, different types of objective functions. In fact, till now whatever problems we have discussed, it is with respect to single objective, and in a real life scenario you may have a problem with multiple objectives, and then we are looking for a kind of solutions which can satisfy all the objectives simultaneously. So, in the that is the case called as goal programming, and in the goal programming you may have a multiple objectives in the first end, and then we are combining these objectives subject to constant and looking for the kind of solution. And this is how the typical structure through which you can actually solve some of the problems. And some of these corresponding to this different kind of structure or the kind of complexity, I will just highlight couple of examples corresponding to kind of complex kind of scenario, where objective functions are not normally follow the kind of typical less than type of constraints or the greater than type of constraints. And in this case, first problem will be like this. You see here, this is a kind of problem where we have a maximization objective functions, and we have a couple of constants here, like budget constraint, then sales volume constraint, machine hour constraint, labor hour constraint, then production cost, other cost, like lots of typical constraints are there. So, we have a multiple constraints, and then the problem is also multivariate kind of structure having 4 different requirement, that is the values of the decision variable, that is typically x 1, x 2, x 3 and x 4, and then some of the constant, more number of constant, and out of all constants. So, first couple of constants are less than type, and then we have another set of constant which are greater than type. So, that means it is a kind of mixture, and then we look for the kind of solution. In this kind of problems, usually graphically we cannot easily reach the optimality or optimum solution, and in this kind of problems we like to solve or looking for the management decision by different approach or different methods, which we call as simplex procedure or the kind of algebraic procedure. So, that means typically you have to write in fact computer programming can be connected, and then we are looking for the kind of solution. Of course, we will connect with solver package, and to solve this kind of problem to get the optimum results, because when the problem is very big and complex, it is not so easy to get quickly manually, and in that context we like to use some of the softwares, maybe R softwares, maybe MATLAB and the kind of solvers to look for the kind of solution. And accordingly, so if you proceed, I can give you more such examples where the situation is kind of the kind of having inconsistent, where some are less than type and the kind of greater than type. So, this is another examples where we have objective functions, and then we have the kind of the objective function is here cost per issue. So, that means technically it is a minimization type of problem subject to 3 constant: protein constants, carbohydrates hydrates constants, then calories. So, like these are all the at least means it is a greater than type kind of situation, and corresponding to this particular problem. So, that means technically, so this is the situation where we can have a less than type of situation, and this is the profit functions, and then the kind of solution. So, that means corresponding to this, so the particular formulation will be minimizing z and subject to all the constant, and typically the issue is here. So, this is actually minimization objective functions, and we have actually 4 constants. So, 2 are greater than type, 1 is less than type, and 1 is equality type, and this is typically different kind of situation. That is actually it is completely mixture type of situation, where we are looking for the optimality, that to minimizing the objective functions, and obviously there is a optimum solution, even if we have a different kind of constants, and accordingly corresponding to this problem. So, the values of the decision variable will be x 1 equal to 1.5, x 3 equal to 10.5, and in fact x 2 is not coming here, and z is coming 0.26. So, that means it is not necessarily that all the values of the decision variable will be active. Sometimes because of constants and the kind of requirement or the with respect to objective function, and some decision variable may be finally dropped. So, that is how we are looking for a kind of structure where you can take care the economic and social aspect simultaneously. That means, if you consider the best structure through which business can be operative, if your objective is not so commercial type of situation, where we like to target more profit, then obviously some of the decision variable may be dropped in the final solution. But in the kind of social kind of setup, where all the decision variables should be operative, and then we look for the higher probability, that could be the best way of kind of representing the situation. But usually we look for the solution as per the management requirement and business requirement, and that too as per the specific objective a specific objective is concerned, so far as business requirement or the kind of management requirement. And corresponding to the particular structure, again I can highlight couple of more problems, and this is actually again 3 decision variable case, and O, B, P, and this is the quantity of 3 different fruits, and then we have actually kind of minimization problem, minimize objective function subject to certain constant here, and so here the constant is first one is the greater than type, and the second one is the equality type, and still we have the optimum solution. And corresponding to this particular problem, where we have actually 3 variables, then finally the optimum solution is coming with respect to 2 variables, that too for x 1 and x 3, and the values of the objective function is also uniquely represented here. So, that means even if the problem is consistent and the constants are not in a kind of unique format, still we can get the optimum solution, and the and there may be the situation where all the values of the decision variable may not be in a kind of positive structure. So, some may be dropped, and finally, we like to fix the kind of optimality as per the specific objective or the management requirement, and accordingly. So, we can have a more such kind of examples, and where we can actually highlight the particular issues, special issues, and there are also similar kind of application in the marketing area, typically media selection, how to allocate and advertising expenditure among different media for advertising, and determination of the optimal assignment of sales people that work for the company among the sales regions, and marketing research, which the objective is to determine the best number of interviews, mailings, phone calls, like that in order to the cost considerations. So, likewise several kind of situation, this is a kind of media selection problem, and corresponding to this these are all actually business kind of facts, and corresponding to the business fact and the kind of condition, the kind of obstacles, the kind of constraints. So, we have to transport the kind of structures to the kind of model, and this is how the basic inputs to this particular problem, and finally again more such inputs, and then finally collect all such inputs and transferring into a kind of model, and this is how the for variable case, that is the x 1, x 2, x 3, x 4s, and depending upon for different means for different ways to put the advertising, that is with respect to radio, televisions, newspaper, and emails, and accordingly the objective function is to maximize a z equal to 7,000 x 1, 50,000 x 2, 18,000 x 3, and 34,000 x 4. That is how the problem structure is, that basic requirement, and then with respect to constant we look for the kind of solution, and again this is a kind of problems where we have a less than type of a constant, greater than type of constant, and then still we are looking for the solution which can give you the kind of optimality. So, this is the less than type structure, this is the greater than type structure, and this is again less than type of structure. Still we are getting the optimum solution, and interestingly in this particular structure here, all the values of the decision variables are at the final kind of structure, and then then the objective function is also satisfactory. So, this is again the kind of structure through which actually we are looking for the solutions, and then you are looking for the kind of management decisions, and this is again similar kind of problems, and some marketing research, kind of design study, conduct marketing survey, analyze data, and like that we have another kind of interesting problem here. Again this is what the informations, and then the particular structure will be divided into different kind of inputs, and corresponding to these inputs we can have a some kind of restrictions, and finally we have the kind of LP structures where we have the objective functions and the constants, and here typically the constants are all are equality type. Still we are looking for the solutions, and then we are actually looking for the kind of management decision. If the constants are equality type by default, then you may not have a kind of a big problem to get the solutions, but still we like to see what is the kind of reality, and then we are looking for the kind of solution. So, in these problems, so we have still solutions, and the values of the decision variable and the kind of optimality of objective function, and this particular problem again can be applied to different financial problems, and this is one typical areas where we can actually apply, like banking decisions, then the kind of portfolio management decision, financial planning. So, so many ways you can actually apply, and one such example is here with respect to financial planning, and issues about 5 different types of loans, and then we are looking for the kind of optimum solution corresponding to these informations, and we like to formulate a problem like here, and here the problem is with respect to 6 variables, and by the way the objective function is the maximization type, and then we have couple of constants, and some are equality type, some are greater than type, some are less than type, and again we have a multiple kind of scenario, and that too with again non negativity restrictions, and still we are looking for the solutions, and having the kind of best solution as per the particular requirement. Now corresponding to this particular situations, so the solution will be like this, and so the solution is against unique kind of situation where all the values of the decision variable are effective, and the the values of the optimum function is also reached. So that means technically we have actually kind of different structure and complexity, still we have the optimality results and the kind of values of the decision variable through which you can actually predict the business environment, and then come for the kind of management decisions. And it can be also in the kind of production area, and like multi period production scheduling, workforce scheduling, and buying decisions, all these things will be there. So this is another kind of structure, monthly requirement, regular production, overtime productions, and subject to typical constraints, and then finally we have the objective function to minimize, and that too with respect to different combination of inputs, and again there are constraints which are less than type, and the kind of greater than type, and the equality type. Still we are this is a very complex problem, still we are getting the optimum solution and the values of the objective functions. Likewise we can have also this particular predictive analytics, that linear programming in different areas. That means the application again with respect to data envelopment analysis, where the linear programming is to measure the relative efficiency of the various departments within an organization, or relative efficiency of two different organizations. So, means this is a kind of efficiency measurement technique, but typically again linear programming and the predictive analytics can be used to get the efficient kind of results, or the kind of environment through which you can actually solve the business problem and come with a kind of effective management decision. So again, so far as DA application is concerned, we can actually look for the align efficiency. So the typical structure of DA is you may have actually input cluster, more number of inputs and more number of outputs, and again linear programming problem can be fitted, and then we can have the kind of efficient solutions. And likewise we have also other application, like we can apply the particular structure in transportation problem, we can apply in the assignment problems, and the kind of project management problems. So that means whatever may be the kind of application area, and if the particular problem is having typical objective, means specify objective, and the kind of constants, the kind of requirements, then the predictive analytics typically the kind of structure what we call as the kind of linear programming structure through which you can look for the solution, and that to optimum solutions, and as a result we can address the problem, business problem, more effectively, and then we can come with kind of management decision as per the particular business requirement. So with this we will stop here, and thank you very much. Have a nice day.